Yesterday what will happen. So there is some problem in app because unable to take the live session through app because that app is not supported yesterday in the morning hour, but evening hour I want to take, but I went to college and come back to here, so much of time it takes place at tight, that's why I unable to take the class. Today I will take the two classes, the first session morning and the evening also I will take the classes, because this Sunday I am not available, that is the 20 and 21st not available in Hyderabad city, I am going to somewhere, so that is why unable to take the class. So please, once again we have to see, this is the last topic in the core syllabus and the middle of the quantum mechanics. Maybe if we finish the linear harmonic oscillator, half of the syllabus of the quantum mechanics of the core syllabus we are finishing. Clear? So later the motion of a central potential, under the motion of the central potential we are discussing the angular momentum, spin angular momentum, spin particle system, spin particle connections, all those things we have to discuss in those things. So that is the entire the different version we have to learn, right. So 4-5 classes I need to take already. This is the third class, linear harmonic oscillator. What is the linear? Linear means it is a one dimensional, harmonic means potential, oscillator means there is a oscillating body. Our ultimate goal is so linear harmonic oscillator wave function and eigenvalue, energy value we have to derive. Already two methods are there. One method we are discussing in the first class only, that method is Schrodinger method. By the Schrodinger wave function we have to solve the wave function of a linear harmonic oscillator and eigenvalue, that is the energy of the linear harmonic oscillator we are solving. That energy level diagram, wave function diagram and probability density diagram also we discussed in previous videos. Clear? Now today we are going to derive the formula for the wave function of a linear harmonic oscillator and similarly energy value of the linear harmonic oscillator by operator method. Already we know that rising operator and lowering operator, a rising operator we also call it as a creation operator, lowering operator we also call it as a annihilation operator. So those operators already we defined, we know that in the last class we are going to define those operators. So now we are going to take the wave function of a linear harmonic oscillator by operator method we need to derive. So for deriving that, first you have to take the rising operator, you have to take operates on any ket. What is going to happen? Already we know that. So the one eigenvalue we are getting, that eigenvalue is root n plus 1 into ket n we are going to get. This is the operator, rising operator or annihilation, the rising operator or creation operator. You have to operate on any ket, you able to get the eigenvalue square root of n plus 1 into root n. Similarly, you have to take a lowering operator, operates on any ket, you are going to get it as a root n into ket n, you are going to get root n into ket n. Now you have to take the first formula, you have to take a dagger. So a dagger ket n, you have to take it as a ket psi n, you have to take, that is the wave function of psi n you have to write. That representation I am changing, root n plus 1 it won't be changed, root n plus 1 only you have to keep. So this one you able to take here, so this is going to write it as a root n plus 1 we are going to get it. So here also you have to write it is psi n plus 1 you have to take. Which one you have to write? It is psi n plus 1 you have to take. Now I am rearranging this equation. Ket psi n plus 1 is equal to, ket psi n plus 1 is equal to 1 by root n plus 1 into 1 by root n plus 1 into a dagger. So ket psi n we have to write, a dagger ket psi n. Now you have to take this expression. From this expression we have to arrange. So what we have to arrange once you have to see. Which one we have to arrange? that is very very important. Ket psi n plus 1 is equal to ket psi n plus 1 is equal to ket psi n plus 1 is equal to 1 by square root of n plus 1 into 1 by square root of n plus 1 into ket psi n, we know this. Ket psi n, we know that value. Clear? So, if n is equal to 0, you have to take if n is equal to 0, what you are going to get it? Psi ket psi 0 plus 1 is equal to 1 by square root of 0 plus 1 into ket psi 0, you are going to get ket psi 0. So, therefore, ket psi 1 is equal to 1 by root 1 is equal to 1. So, therefore, ket psi 0, you are going to get ket psi 1 is equal to ket psi 0. So, this one what we have to write it is a dagger also is there, a dagger. So, a dagger also is there, correct. A dagger you have to write it is a dagger into ket psi n, you are going to get it. Clear? Now, you have to take if n is equal to 1, you have to consider. If n is equal to 1, you have to take so what is going to happen, you have to see ket psi 1 plus 1 is equal to ket psi 1 plus 1 is equal to a dagger into is divided a dagger into ket psi 1 is divided by which one we have to write, it is square root of 1 plus 1 we are writing. So, 1 by root 2 into a dagger ket psi 1, a dagger ket psi 1. So, now you have to write it is 1 by root 2 into a dagger ket psi 1 is equal to a dagger ket psi 1. So, we have to apply a dagger ket psi 1, a dagger you have to keep like that, ket psi 1 is equal to a dagger into ket psi 0, a dagger into ket psi 0. So, therefore, what we have to write 1 by root 2 into a dagger into a dagger whole square into ket psi 0 we have to write which is equal to ket psi 2 is equal to ket psi 1 plus 1 is equal to ket psi 2. So, therefore, ket psi 2 is equal to 1 by root 2 into a dagger whole square into ket psi 0 you are going to get. Similarly, you have to take actually what is our ultimate one, ket psi n plus 1 is equal to 1 by square root of n plus 1 into a dagger ket psi n. This is the value, this is the formula. So, a dagger ket psi n. Now, if you have to take if n is equal to 1 is 0 1, if you have to write it as n is equal to 2. So, what is going to happen, you have to see ket psi 2 plus 1 is equal to 1 by square root of 2 plus 1 into. So, a dagger, so ket psi 2 you are going to get. Already we know that 1 by root 3 into a dagger psi 2 is equal to, in the previously we are discussing what is your psi 2, 1 by root 2 a dagger whole square into ket psi 0, 1 by root 2 into a dagger whole square into ket psi 0, this is the psi 2 value, ket psi 2 value. So, therefore, what we have to write it is 1 by 3 into 2 into 1. So, this is the 3 into 2 into 1. We have to rearrange this, a dagger whole square into a dagger whole cube. So, this is ket psi 0. So, this one what we have to write it is 1 by square root of 3 factorial into a dagger whole cube into ket psi 0 we have to write. So, this is which is equal to ket psi 3 is equal to how much value you are going to get, ket psi 3 is equal to, we are going to get that 1 by root 3 factorial into, so a dagger whole cube into psi 0 and so on. You have to take first you have to write it is ket psi 1 is equal to, what we have to write it is
1 by square root of 1 factorial into a dagger into ket psi 0. So, 1 ket psi 2 is equal to, what is your ket psi 2? 1 by square root of 2 factorial into a dagger whole square into ket psi 0, a dagger whole square into ket psi 0. 1 by psi 3 is equal to, ket psi 3 is equal to 1 by square root of 3 factorial into a dagger whole cube into ket psi 0, correct? And so on you have to take ket psi n is equal to, ket psi n is equal to 1 by n factorial, n factorial. So, a dagger whole to the power of n into ket psi 0. This is the stationary state function for A in the Dirac notation. What is the stationary function in the Dirac notation? You have to see here, ket psi n is equal to 1 by n factorial into a dagger whole to the power of n ket psi 0. This is very, very important. This formula is generalized formula, for that we have to remember. So, not only that, so if you want to derive the linear harmonic oscillator wave function, first any lowering operator you have to take, any lowering operator you have to operate on ket n. So, what is going to happen? So, that is the lowering operator, the ket n you have to take, so that n is equal to 0. So, you have to write it is ket 0 you have to apply. 0 is the lowered state, below that state there is no state, so that is why you are going to get it as a 0, because a dagger A is the lowering operator. Which one it is? A is which operator? This operator is a lowering operator. Any lowering operator you have to operate on a lower state, that another lower state is not there. So, that is why it is not 0. Otherwise, if you have to take a dagger A also you have to apply it on a lower state. So, what will happen? This state is going to 0, 0 into something is equal to, you are going to take it as a 0 only you have to get. So, what is this a dagger A? This operator is occupation operator or number operator. After some time I have to teach what is the number operator. So, this operator we also call it as a occupation number operator, occupation number operator. This operator we also call it as a occupation number operator also. A dagger A is equal to. So, these two things we know that. So, from these two things what we have to write here, once you have to see, first we have to take A, you have to apply on ket 0 is equal to 0. What is that meaning? A psi 0 is the lowered state, that is the ground state. Below the ground state there is no state is existing according to our view. So, therefore, you have to apply on the lower operator on a lower state. So, one state should be lowered. There is a negative states here. So, that is why that is going to take it as a 0. Already we know that, already we defined. So, what is our lowered state? 1 by square root of 2m into h cut omega, 1 by square root of 2m into h cut omega into m omega x cap plus ip x cap is there, ip x cap. This is the lowered state operator, already we defined in the previous classes, into psi 0 is equal to 0, is equal to 0. So, therefore, this division it going to the multiplication, 0 into something is equal to 0. So, therefore, m omega x cap plus ip x into psi 0 is equal to 0, you are going to get it. So, therefore, m omega x cap into psi 0 which is equal to minus ip x into psi 0, you are going to get it. So, therefore, what we have to write, m omega x cap into psi 0 is equal to minus ip x cap is equal to h cut by I into dou psi 0 is divided by dou x, I get cancel, you are going to get it as a minus h cut into, so minus h cut into dou psi 0 is divided by dou x, which is equal to m omega x cap into psi 0 is equal to. So therefore what we have to write here, once you have to see m omega x cap into psi 0 is equal to minus h cut into dou psi 0 by dou x, dou psi 0 by dou x. I am rearranging this expression. How we have to rearrange? Dou psi 0 is divided by psi 0. This one you have to bring into this side, this one you have to bring into this side. So what will happen? You have to see dou psi 0 by dou psi 0 by psi 0 is equal to m omega x cap is divided by h cut into dou x minus you have to take here. Clear? So now you have to integrate on both sides. Dou psi 0 is divided by psi 0 integral. This is the integral is equal to minus integral m omega x cap is divided by h cut into dou x. So there is a integral constant is there, that integral constant, because there is no limits are there, that's why we have to use the integral constant. ln psi 0 is equal to minus, which one we have to write it is minus 1 by 2 into m omega x square is divided by h cut, m omega x square is divided by h cut plus ln a you have to take. This is the integral constant you have to see. This ln a you have to bring into this side. ln a minus ln b is equal to ln psi 0 by a. ln psi 0 by a is equal to minus 1 by 2 into m omega by h cut into x square. m omega by h cut into x square you have to write it is. So therefore, so what is going to happen? You have to see here ln psi 0 is divided by a is equal to ln psi 0 is divided by a minus m omega is divided by h cut 2h cut into x square, minus m omega is divided by h cut into x square. But you know that where alpha square is equal to, where alpha square is equal to m omega by h cut, so alpha square is equal to m omega by h cut. So therefore you have to substitute here ln psi 0 is divided by a is equal to, so minus alpha square x square is divided by 2, because alpha square is equal to m omega by h cut. Now you have to remove the logarithm. So what is going to happen? You are going to get it as a psi 0. Psi 0 is equal to a into exponential of which one we are going to get, minus alpha square x square is divided by 2, you are going to get. This is the ground state wave function of a linear harmonic oscillator. But here a is there. What is the a? A is the normalized constant. A is a constant. This constant we need to calculate. How we have to calculate the constant? By using the normalization condition, we need to calculate the this constant. So by the normalization condition, what is the formula for the normalization condition? Maybe I have to teach this one is the postulates of quantum mechanics. Normalization condition I have to take. So what is our normalization condition? The normalization condition is integral minus infinite to plus infinite modulus of psi whole square into dx is equal to 1. This is the normalization condition, formula for the normalization condition. Once we know the normalization condition, we have to substitute the a value minus infinite to plus infinite. Modulus of psi naught square means modulus of a square, that is the amplitude you have to write it is modulus of a square into, so which one we have to write it is exponential of minus alpha square x square is divided by 2 into dx, which is equal to 1. This a square you have to take outside. So, integral minus infinite to plus infinite e to the power of minus x square whole square is equal to exponential of minus alpha square x square into dx, which is equal to 1. But you know the standard integration. What is your standard integration? Integral minus infinite to plus infinite e to the power of minus ax square dx is equal to root 5 by a. So, root 5 by a, this expression you know that already, this formula we are going to get it, we are using. So, therefore, a square into integral minus infinite to plus infinite exponential of, instead of a is equal to, which one is there? Alpha square is there. So, therefore, root 5 is divided by root alpha square. So, root 5 is divided by root alpha square, which is equal to 1. So, the square 1 get cancelled. Therefore, a square is equal to, what we have to write it is alpha by root 5. A square is equal to, what is that value? Alpha by root 5. So, therefore, a is equal to the square root of alpha by root 5. A is equal to square root of alpha by root 5. This is the normalization condition. This normalization condition you have to substitute there. So, therefore, psi 0 is equal to a into exponential of minus alpha square x square is divided by 2. So, a square minus x square is divided by 2. But you know that a value, the square root of alpha is divided by root 5. So, this is the a value into exponential of, which one we have to write it is minus alpha square x square is divided by 2 you are going to get. This is the which wave function? This wave function we call it as a ground state wave function of a linear harmonic oscillator. This wave function is ground state wave function of, this wave function we call it as a ground state wave function of linear harmonic oscillator. This wave function is ground state wave function of a linear harmonic oscillator. Linear harmonic oscillator ground state wave function is equal to psi 0 is equal to square root of alpha by root 5 exponential of minus alpha square x square is divided by root 2, where alpha is equal to, what is your alpha? Your alpha is equal to m omega by square root of m omega by h cut. So, this is the alpha. Alpha square is equal to m omega by h cut. Alpha square is equal to, what is your value? M omega by h cut. You are going to get it. Now, we need to take another wave function, not ground state, first excited state wave function we need to calculate. How we have to calculate the first excited state wave function? Already we know a dagger you have to apply on ket n, you are going to get it square root of n plus 1 into ket psi n plus 1 we are going to get. So, you know that psi n plus 1 is equal to ket psi n plus 1 is equal to 1 by square root of n plus 1 into a dagger into ket psi n. A dagger into ket psi n we are going to get it. A dagger into ket psi n, clear. So, that is the value we are going to take. So, from this value you have to substitute that value, ket psi n plus 1 is equal to, or psi n plus 1 is equal to, ket psi n plus 1 or psi n plus 1 is equal to 1 by square root of n plus 1 into 1 by square root of n plus 1 is into a dagger is equal to 1 by square root of 2m into h cut omega into, which one we have to write it is m omega x cap minus ip x cap into ket psi n, you have to write it is ipx cap into ket psi n. So therefore, so we have to rearrange this expression. How we have to rearrange? 1 by square root of 2 into n plus 1 I am writing. So is divided by 1 by square root of m omega into h cut, right. So we have to take it as a m omega x cap minus ip x cap into psi n, m omega x cap plus ipx into psi n, which is equal to psi n plus 1. Clear? Now we have to take, so which one we have to take? This term you have to take inside the bracket. So what is going to happen? You have to see here the square root of, so psi n plus 1 is equal to 1 by square root of 2 into n plus 1, 1 by square root of 2 into n plus 1. You have to take the inside. So what is going to happen? So square root of m omega by h cut into x cap. So we have to get it is square root of m omega is divided by h cut into x cap minus I into, we have to take minus I into p x cap. You have to write it is which one we have to write? You able to take inside. So p x cap into dou by dou x you have to take. So there, so you have to write it is dou by dou x you have to write. So therefore what you are going to get it, I into 1 by square root of m omega h cut into, so p x cap is equal to h cut by I into dou by dou x, h cut by I into dou by dou x into psi n we have to write. It is clear? So therefore, so again I am rearranging the term. Psi n plus 1 is equal to, psi n plus 1 is equal to 1 by square root of 2 into n plus 1, right. So m omega square root of m omega is divided by h cut into x cap minus I into, I have to rearrange this. So h cut is divided by m omega, square root of h cut is divided by m omega, this I get cancelled. Therefore dou by dou x into psi n we have to write it is. But you know that alpha is equal to square root of m omega by h cut. This is the alpha value. Alpha is equal to square root of m omega by h cut. So therefore psi n plus 1 is equal to 1 by square root of 2 into n plus 1, 1 by square root of 2 into n plus 1, square root of m omega by h cut is equal to alpha into x cap minus 1 by alpha into dou by dou x of psi n. You have to write it is dou by dou x of psi n. You able to take? Clear? So this is the value you have to see. If so, you have to take this value. After taking this value, so this equation we have to rearrange. So what is going to rearrange? Once you have to see psi n plus 1 is equal to, what we are going to get it? Once you have to take here psi n plus 1 is equal to 1 by square root of 2 into n plus 1, 1 by square root of 2 into n plus 1 into alpha into x cap minus which one? 1 by alpha into dou by dou x of psi n we are going to get. This expression we are going to get. Clear? So here, so you have to keep, put n is equal to 0, you have to keep n is equal to 0. If n is equal to 0, you able to get it, psi 0 plus 1 is equal to 1 by square root of 2 into 1 plus 0, 0 plus 1 into 2, 2 you have to get it. So you are going to get alpha into x cap minus 1 by alpha into dou by dou x, the n is equal to 0 you have to write. That is the psi 0 you able to take. So therefore psi 0 plus 1 is equal to, what is this value? Psi 1. This is the first excited state wave function. This wave function is first excited state wave function. First excited state wave function is equal to this wave function we are going to write it as a first excited state wave function, that is psi 1 is equal to 1 by square root of 2 into alpha into x cap minus 1 by alpha into dou by dou x of psi 0. Psi 0 already we are finding that ground state wave function. What is that ground state wave function? Square root of alpha by, so root 5, square root of alpha by root 5, square root of alpha by root 5 into e to the power of exponential of minus alpha square x square is divided by 2. So this is the value you are going to get it, clear. So now this entire the term you have to take inside. So before going to that inside, we have to take it as a the square root of alpha is divided by 2 to the power of 1 factorial root 5 I have to write. So root 5 into, so into alpha into x cap into exponential of, we have to write it is minus alpha square x square is divided by 2. So I have to bring inside minus 1 by alpha into dou by dou x of, dou by dou x of exponential of, which one we have to write, minus alpha square x square is divided by 2, we need to substitute, clear. So therefore what we are going to get, we are going to get the first excited state, the first excited state wave function psi 0 is equal to square root of alpha is divided by 2 to the power of 1 into 1 factorial into root 5 alpha by root to the power of 1 into 1 factorial into, so 1 factorial, this is 1 factorial into root 5. So we have to into, be able to take, so what is that, alpha into x cap exponential of alpha into x cap exponential of minus alpha square x square is divided by 2, alpha square x square is divided by 2 minus 1 by alpha into, minus 1 by alpha into, we have to differentiate that one. So what is going to happen, you have to see e to the power of minus x square alpha square, e to the power of minus x square alpha square is divided by 2 into, again you have to differentiate this one, alpha square by 2 into minus 2x, you are going to get it. So 2 1 ja, 2 1 ja get cancel. So therefore how much you are going to get, so alpha is divided by 2 to the power of 1 into 1 factorial into root 5, you are going to get it is alpha into x exponential of minus alpha square x square is divided by 2 into, so we have to write it is 1 alpha get cancel, minus into minus plus, you have to going to get plus alpha into x, so we have to write it as exponential of minus alpha square x square is divided by 2. So therefore, so plus plus you are going to get it as a, this entire thing is, this is 1 plus 1 is equal to 2. So therefore psi 1 is equal to, the first excited state wave function is equal to square root of alpha is divided by 2 to the power of 1 into 1 factorial into root 5. So this is we have to write it is 2 alpha x into exponential of minus alpha square x square is divided by 2. So this is the first excited state wave function of the hydrogen atom. So therefore psi 1 is equal to, again I am rearranging once, you have to see alpha is divided by 2 to the power of 1 into 1 factorial into root 5. So exponential of minus alpha square x square is divided by 2 into, so 2 alpha x. So we have to write it, this is the 2 alpha x, this is the first excited state, this is what it is, this is the first excited state, first excited state, first excited state wave function, first excited state wave function of whom, wave function of linear harmonic oscillator. This is the first excited state wave function of the linear harmonic oscillator. From this, what is going to take once you have to take here we are discussing the first ground state wave function. This is the ground state wave function. The ground state wave function of a linear harmonic oscillator. The ground state wave function of the linear harmonic oscillator is equal to square root of alpha by root 5 into square root of alpha by root 5 into exponential of minus alpha square x square is divided by 2. So, this one I have to write it is how I am rearranging once you have to see psi 0 is equal to square root of alpha is divided by 2 to the power of 0 into 0 factorial into root 5, 0 into 0 factorial into root 5, exponential of minus alpha square x square is divided by 2 into h0 of alpha x. We have to write it is this polynomial, we call it as a, which polynomial it is? Hermite polynomial. So, already we discussed in the previous classes in mathematical methods of physics also I told about the Hermite polynomial. H0 of alpha x is equal to how much it is? H0 of alpha x is equal to 1. Now, you have to write it is the second excited state. You able to take the the first excited state that is psi 1 is equal to what is going to write it is psi 1 is equal to alpha by 2 to the power of 1 into 1 factorial into root 5. So, exponential of minus alpha square x square is divided by 2 into this one we have to write it is h1 of alpha x. So, this is also Hermite polynomial where h1 of alpha x is equal to how much you have to write it is 2 into alpha x we have to take it as. The similarly you able to take a psi 3 is equal to what you are going to write it is square root of alpha by 2 to the power of. So, which one we have to write here? So, psi 2 you have to take psi 2 is equal to 2 to the power of 2 into 2 factorial into root 5. So, into root 5 exponential of we have to take minus alpha square x square is divided by 2 into h2 of alpha x. H2 of alpha x is equal to how much you are going to get 4 alpha x whole square minus 2 you are going to get it. This is the Hermite polynomial already we discussed. So, not only that, so you keep on you have to take so and so on you have to psi 3 you have to take it as psi 3 square root of so which one we have to write it is alpha by 2 to the power of 3 into 3 factorial into root 5. So, exponential of which one we have to write it is minus alpha square x square is divided by 2 into h3 of so alpha x we have to write it is. So, like that and so on you able to take. So, now you able to write it is psi n of x is equal to for nth state wave function of a linear harmonic oscillator is equal to square root of alpha is divided by 2 to the power of n into n factorial into root 5 exponential of which one we have to write it is minus alpha square x square is divided by 2 into hn of alpha x we have to write it is. This is the hn of alpha x, which one it is? This is a nth state of the linear harmonic oscillator wave function. Already this wave function I gave in the first class of the linear harmonic oscillator also. Now, from this wave function I have to conclude that so what is going to conclude once you have to see. Therefore, the wave function of a linear harmonic oscillator, the wave function of a linear harmonic oscillator is equal to the wave function of a linear harmonic oscillator is equal to psi n of x is equal to square root of alpha is divided by 2 to the power of n into n factorial into root 5 exponential of minus alpha square x square is divided by 2 into hn of alpha x. We have to write it is, this is the hn of alpha x. From this we have to write it is, when it will be acted as this psi n of x is equal to even. So when it will be even or when it will be odd, you have to see. So even for even values of n, for even n values, it is going to take it as a even. If it is odd, so for odd n values, it is going to take it as a odd, you have to write it is. For odd n values you are going to take it as a odd. For even n values means n is equal to 0, 2, 4, 6 and so on. Here odd n values is equal to 1, 3, 5, 7 and so on, you have to get. So why it is going to get, this function is even function only, this function is even function. Here hn of x is changing. How it is changing hn of x? It is hn of x is even for even n values. Hn of x is even for even n values, even for even n values, that n is equal to 0, 2, 4, 6 and so on. So if this is odd, you are going to take it as a odd. For n is equal to odd n values, so n values you have to, for odd n values you able to write it is, for odd n values you are going to write it n is equal to 1, 3, 5, 7 you have to take and so on, you able to get. For odd n values, this is the value of that one, the odd function you able to get. But even n values, even function, because of that, so you are going to get it. Clear? So based on the Hermite polynomial, already one time they are asking the question. So in our examination, maybe last JL examination also, 2023 JL examination, 2023 JL, people are asking, in linear harmonic oscillator, which wave function we are using? Hermite polynomial we are using. Which polynomial we are using? Hermite polynomial we are using. So like that also questions you may get in your competitive examination. Clear? So this is very, very important. So not only that, so now we are discussing about the wave function of a linear harmonic oscillator. Now we are continuing into energy of a linear harmonic oscillator. How we able to derive the energy of the linear harmonic oscillator? Once you have to see. So bra m, so H, that is the Hamiltonian operator, operates on cation. What is going to happen? So this is the energy value you are going to get En, and bra m cation you are going to get, that is the inner product. So another representation also you have to take this one. Bra m, the Hamiltonian operator H, cation, is equal to En into Kronecker delta Mn, we have to write it is this En. What is your En? This En is the energy value of a linear harmonic oscillator. This En is the energy of linear harmonic oscillator, or this energy value we also call it as a eigenvalue of the linear harmonic, eigenvalue of the nth state. We have to write it is eigenvalue of the nth state of linear harmonic oscillator. The eigenvalue of the energy value of the linear harmonic oscillator, or eigenvalue of nth state of the linear harmonic oscillator. Which one it is? That is the En value, that is the energy value how to take. So now we are going to get the En value. For going to get it as a En value, I am going to one procedure I have to follow. So what is that procedure? Once you have to see, we need to calculate the energy of a linear harmonic oscillator. Clear? So now we know that Brian A dagger A cation, we have to write it is Brian A dagger A cation. We know that A dagger A is equal to A H by H cap is divided by H cut omega minus 1 by 2 into cation. So this is the expectation value how to take. So what is going to happen? So you have to see 1 by H cut omega into Brian expectation value of n into cation minus 1 Brian. So 1 by 2 into, so cation is there. So therefore what we have to write it is 1 by H cut omega into En minus 1 by 2. Brian cation is equal to 1. So this expression you have to take it as a expression number 1 you have to take. So what you have to write it is Brian A dagger A cation is equal to, we have to write it is En is divided by H cut omega minus 1 by 2. This is the Roman equation number 1 you have to take. Similarly, I have to take the same expression Brian A dagger A into cation. So you have to take it as a cation. So this one I am rearranging. How you have to rearrange once you have to see Brian. So A dagger. So instead of cation I have to take as a completeness relation. I have to keep so A into cation I have to write it is. So therefore Brian A dagger according to the completeness relation, that is a outer product, that is the Ket-Bra product. So this is the, which is equal to what it is, completeness relation. Which one it is? Already we are discussing in the postulates of quantum mechanics. This relation we call it as a completeness relation. Once you have to take the completeness relation into ket an, we have to write it is. Clear? So now we have to rearrange this. How we able to rearrange? So Brian A dagger it will become as a and cation, this is old dagger you have to take. So you able to get the same thing you are going to get. So Brian A into cation. So A dagger into A is equal to A conjugate, that is the modulus of A it will come. So Brian A cation. So modulus whole square we have to write. This is obviously is greater than or equal to 0. This expression you have to take it as A. Which expression? Equation number 2 you have to take. This is the equation number 1. This expression you have to take it as the equation number 1. This expression you able to take equation number 2 you have to take. Brian A dagger A cation. Brian A dagger A cation you have to take. This is the equation number 2. From equation number 1 and 2 you have to see the left hand side equal. So therefore what we have to write? So what is the left hand side equation is equal. So that's why the right hand side also you able to write it is what is the equation? Once again I have to write the equation. So Brian A dagger E into A cation is equal to H cap is divided by H cut omega minus 1 by 2. This is the equation number 1. In the same thing you have to write Brian A dagger into A cation is equal to, so modulus of Brian we have to write it as a modulus of Brian. So A cation, so whole square is greater than or equal to 0. This is the equation number 1. So therefore what we have to write? The left hand side part is equal. That's why I have to equate the right hand side part. From the equation number 1 and 2, from the equation number 1 and 2 we have to write it is that expectation value of En. So this one is going to take it as a energy value En you have to write. So En is divided by H cut omega minus 1 by 2 is greater than or equal to 0. If this is greater than or equal to 0, so this one also greater than or equal to 0, you have to rearrange this En, so is divided by h cut omega is greater than or equal to 1 by 2. So therefore what we have to write it is En is equal to, so what is the thing you have to take, En is greater than or equal to h cut omega is divided by 2. So what is that meaning? En must be greater than or equal to h cut by omega by 2. So therefore, so ground state energy E0 is equal to what you are going to get, h cut omega by 2. This is the ground state energy. The first excited state obviously is greater than the h cut omega by 2 only it will come. So this energy we call it as a ground state energy of ground state energy. This energy we call it as a ground state energy of linear harmonic oscillator. This is very very important. This energy we call it as a ground state energy of linear harmonic oscillator. Now we need to calculate the first excited state and second excited state and nth state. So what we are going to get, what is our answer we able to see. First we are taking the Hamiltonian operator. So you have to operate on any ket. So any ket n, you are going to get it as the eigenvalue n, and same ket you are going to get, this is the eigenvalue expression you have to write it is clear. So suppose you have to take a lowering operator a cap, so you operates on left hand side of that expression, you are going to get how much you are going to get, this is the En is the eigenvalue a into ket n you are going to get. So but you know that, so what you know, you already we know that commutator a comma h is equal to, commutator a comma h is equal to h cut omega a. Already in the previous classes we are discussing h minus ha is equal to h cut omega into a. We need to calculate the h value, we want to get it, h is equal to ha plus h cut omega into a, ha plus h cut omega into a. So therefore this value have to substitute, therefore h is equal to, which one we have to write it is ha plus h cut omega a into ket n, which is equal to En into a, so into ket n we have to write it is clear. So now you have to take this term, you have to take to outside, you have to take ha into ket n is equal to, ha into ket n is equal to, what is going to happen, En minus this h cut omega coming into this side minus h cut omega into a, so into which one we have to write it is ket n you able to take. So what is going to happen, you have to operate on the lowered operator, the energy value is lowered, energy value is coming, so therefore it is lowered by whom, so lowered by h cut omega, so lowered by h cut omega. Clearly similar thing you have to take, so now you able to consider h you have to take, similarly you have to write it as you have to apply on ket n, so there is a eigenvalue expression En and ket n you have to write, so you have to multiply with a dagger, you have to multiply a dagger into h, ket n is equal to En into a dagger into ket n you have to get it. So but you know that commutator a dagger with Hamiltonian, you know this, commutator a dagger with Hamiltonian is equal to minus h cut omega into a dagger. So this value already you know that, you have to split the a dagger into h minus h into a dagger, which is equal to minus h cut omega into a dagger, you have to write a dagger into h is equal to, we have to write it is h into a dagger minus h cut omega into a dagger is there. So this value have to substitute there. So what is that value? A dagger into H is equal to, we are going to write it is H into A dagger minus H cut omega into A dagger into ket n, which is equal to En into A dagger into ket n we are writing. So now this one you have to bring into this side. H into A dagger ket n is equal to En, we are going to get it as a plus H cut omega into A dagger ket n. From this what we have to write it is here one state is raised one state, clear. So raised by H cut omega. So how much it is raised by the H cut omega. So if you have to operate the rising operator, it raised by the H cut omega. If you have to operate the lowering operator, it is lowered by the H cut omega, clear. So now we know that, already we know what you know, A dagger A, that is A dagger A, you have to operate on the 0 ket, you able to get it as a 0 because A dagger A is lowered, again the lowered you are going to get it as a 0. So but A dagger A is equal to H by H cut omega minus 1 by 2 into ket 0 is equal to 0. Here you have to take here, so ket 0 is not equal to 0 because ket 0 is equal to square root of alpha by root 5 e to the power of minus alpha square x square is divided by 2, you are going to get it. So that's why you able to take so ket 0 is not equal to 0, so that's why which is equal to 0, this term is equal to 0, H cap is divided by H cut omega minus 1 by 2 is equal to 0, you have to going to get it. So therefore this term, so what energy value you are going to get, that energy value how to take it as a En, you have to write it is, this is the En means E0 you have to write. So therefore E0 is divided by H cut omega is equal to 1 by 2, E0 is equal to H cut omega is divided by 2. This energy is the ground state energy of linear harmonic oscillator, ground state energy of linear harmonic oscillator. This energy we also call it as a 0 point energy of the linear harmonic oscillator, ground state energy or 0 point energy of the linear harmonic oscillator. So you have to use that one, E0 is equal to H cut omega is divided by 2, ground state energy or 0 point energy. 0 point energy means this is the ZPE, ZPE of whom, ZP of a linear harmonic oscillator, clear. So not only that, so we have to use one more important thing, we need to calculate the En value, you need to get it. Suppose you have to take here H cap A dagger ket n is equal to H cap A dagger ket n is equal to what you are going to get it, that is 0 E0 H cut omega E0 H cut omega. So you have to take, instead of n is equal to 0, E0 H cut omega A dagger into ket 0 you have to write it, A dagger into ket 0. So therefore, so what is going to happen, E0 is equal to H cut omega is divided by 2 into H cut omega A dagger, so ket 0 is equal to 3 by 2 H cut omega, 3 by 2 H cut omega into A dagger ket 0 you have to get it, clear. So not only that, suppose if you have to take here, so H cap A dagger ket 0 is equal to H cap A dagger ket 0 is equal to, this is the first excited state energy value. So this energy value how to take it as a, which one, this is the E1, what is your E1, first excited state, first excited state energy value, first excited state energy value of ohm, energy value of linear harmonic oscillator. Similarly you have to apply H cap, So A dagger, one more time you have to apply on the, so this ground state wave function. What is going to happen? You able to take it as a, so E1 plus h cut omega. So E1 plus h cut omega into A dagger ket 0, you are going to get it. So therefore how much you have to get? This is the 5 by 2 h cut omega into, so A dagger 5 by 2 h cut omega into A dagger into ket 0 you have to get. So this is the 5 by 2, you are going to take it as a E2. So what is this E2? This is the second excited state, second excited state energy of ohm, second excited state of energy of a linear harmonic oscillator. So not only that, so you have to prolong, so you have to repeat the A dagger n times, you have to repeat, so n times you have to repeat, n times repeat, so repeat n times you have to repeat, so which one you have to operate, or n times you have to repeat, n times you have to repeated, n times repeated, you able to get it as a En, you are a repeated A dagger. So therefore what you are going to get? You are going to get it as a En is equal to E0, that is the ground state energy, plus n into h cut omega you are going to get. So suppose you have to write n times E0, that is n into h cut omega you are going to get. So from this what you have to write, it is En is equal to E0 is equal to h cut omega by 2 plus n into h cut omega by 2. So therefore En is equal to h cut omega by 2, you have to take the common. So n plus 1 by 2 into h cut by omega by 2, where n is equal to, 0, 1, 2, 3 and so on it will come. This is the beauty of the linear harmonic oscillator. So what we have to write? This is the energy of linear harmonic oscillator, energy of a linear harmonic oscillator, energy value of the linear harmonic oscillator. It is a very, very important one, you have to utilize this one. Clear? Not only that, some more two important things I have to teach in this video. One is the number operator, another one is occupation number operator. What is the number operator? We also call it as a occupation number operator. How we able to define? First you have to see the number operator. So the number operator we have to define as a dagger A. So A dagger A, you have to operate on any function, you able to get it as a number. Once you have to take A dagger A is equal to, already we know that h cap by h cut omega minus 1 by 2. This is the A dagger A value is equal to. But so h value have to write it is A dagger A plus 1 by 2 is equal to, so into h cut omega is equal to h cap. This is the Hamiltonian operator we have to apply. So this is the equation number 1 you have to take. Which equation? This equation we have to, 1 you have to write it is, first we know that according to the linear harmonic oscillator, h cap you have to apply on n, En into ket n you are going to get. So but you know that h cap into ket n is equal to, so what is the En? N plus 1 by 2 into h cut omega into ket n you are going to get. This is the equation number 2. Now you have to see here, so what is going to happen? Here you able to take h cap is equal to A dagger plus A. So we have to apply the equation number 1 here. So A dagger plus A plus 1 by 2 into h cut omega into ket n is equal to n plus 1 by 2 into h cut omega into ket n. Here you have to apply the ket n is same, h cut omega is same, 1 by 2 is same, left side and right side. So therefore n is equal to which one it is? N is the number. Here n is a number. So instead of number, so what is there? One operator is there. This operator we call it as a, which operator it is? Number operator or occupation operator. This operator we call it as a number operator. This operator we also call it as a occupation operator. Clear? So therefore a dagger a is equal to what we have to write it is, therefore we have to write a dagger a is equal to, that is the number operator. So this operator we call it as a number operator. Therefore the number operator you have to operate on get one number it will come. So that number is n, you have to take it as a n, you able to write it is. Clear? So that is the way you have to write it is. So therefore this is the number operator. What are the properties of the number operator? First property is number operator is a Hermitian operator. Number operator, what is the first property? Number operator is a Hermitian operator. Which operator it is? Number operator. We also call it as a Hermitian operator because the number operator, so the number operator old dagger is equal to number operator only you are going to get. So or a dagger a old dagger is equal to, you have to going to get a dagger a only you are going to get. This is the number operator is a Hermitian operator. Clear? So not only that, some more problems also you have to see. First you able to take so problem number 1 you have to take number operator into a, you have to take which is going to get it as a, which one we have to write it is minus 8 will come. So you have to simplify, the number operator is equal to a dagger a into a. Already we know that according to the distributive property ab comma c is equal to a into commutator b comma c plus a comma c into commutator b, you have to write it is. So therefore you able to take ABC you have to apply here. So a into a dagger into commutator a comma, so commutator a comma a, so plus which one we have to write it is a dagger comma a, commutator a dagger comma a into a. Every operator commutes with its own operator, that is going to 0. 0 into something is equal to 0. So a dagger, so a commutator a dagger a is equal to minus 1 into a. So therefore you have to get it as a minus a, you have to get it. So not only that, based on that you have to take the second one, number operator you have to take it as a, so you able to get it as a dagger, you have to apply plus a dagger, you are going to get it. How much you are going to get it? So the similar passion you have to do, you able to get the, so plus a dagger you are going to get the, maybe you able to get it in your competitive examination. So these things. So not only that, we need to represent the momentum and position operators in terms of the a dagger and a. So what is our a dagger is equal to, we know that a dagger is the rising operator 1 by square root of 2m into h cut omega into m omega x cap minus ip x cap. This is the position of a dagger operator. So a is equal to 1 by square root of 2m into h cut omega into m omega x cap plus ip x cap is there. This is which one it is? This is the lowering operator. Now you have to add this, a dagger plus a is equal to, a dagger plus a is equal to 1 by, you have to write it as this one and this one is get cancelled, you able to take it as a common 1 by square root of 2m h cut omega, you have to take the common here, m omega x cap, m omega x cap, 2m omega x cap, you are going to get it. Now you have to simplify, 2 1 ja 2 1 ja get cancel. Therefore, what is going to write it is, here you have to take it as a, what we have to write, so a dagger plus a is equal to, so we able to take it as a square root of, you have to write it as a 2 m omega h cap, m omega is there, so we have to write it as a square root of 2 m omega is divided by h cut into x cap is there. So x cap, so therefore the position operator x cap is equal to, in terms of a dagger and a, what we have to write it is, x cap h cut is divided by 2m omega into, what we have to write it is, a dagger plus a. This is the position operator in terms of what it is, in terms of a dagger and a. So x cap is equal to h cut is divided by 2m omega under root a dagger plus a. This is the position operator. Which one it is? Position operator in terms of position operator in terms of what? Position operator in terms of a dagger, rising and lowering operators. So not only that, so we have to take as a, you have to subtract these two things. Momentum operator we need to write it is, a dagger is equal to 1 by square root of 2m h cut omega into m omega x cap minus ip x cap is there. So this is the rising operator. That lowering operator is equal to 1 by square root of 2m h cut omega into, so m omega x cap plus ip x cap is there. So this is the lowering operator. Now you have to subtract these equations. So what is going to happen? You have to see here. So minus it will come. So therefore a dagger minus a is equal to 1 by square root of 2m h cut omega into, so m omega x cap minus plus get cancel. Here minus 2i p x cap is there. Minus 2i p x cap is there. But you know that what we have to write it is, so a dagger minus a is equal to, we are going to write it is, so how you able to take, here you have to cross multiply p x cap, you have to take here. So you have to divided with I and multiplied with I square it will come, I square into I square is equal to minus into minus plus it will come I into, so we have to write it as a, this is the root is there, here we able to take m omega h cut is divided by 2, I into m omega h cut is divided by 2 into a dagger minus a. So this is the position, this is the momentum operator, I into square root of m omega is divided by 2, so h cut is divided by 2, a dagger minus a. This one it is a momentum operator. Which operator it is? Momentum operator in terms of what? Momentum operator in terms of rising and lowering operators. Clear? So like this we have to do in our competitive examination, because big derivations I am deriving to you. So don't feel bad, you have to practice, then only you will able to get the perfection. This is the quantum mechanics. The style of the function of the reading the quantum mechanics is like this only. You have to practice and you have to inform to your friends who are weak in quantum mechanics. So please make them purchase our course, so they will get the benefit to teach to the quantum mechanics of their students. Thank you so much. So be practice. Thank you.